Hello guys, welcome back to YT Classroom. Today we'll be solving AS Level Physics 9702, Paper 2, Variant 2 from Feb-March 2025. This is a 1 hour 15-minute paper and it's a 60-mark paper, and this is one of the three papers for the AS Level Physics 9702, which are paper 1, which is MCQ paper, paper 2, which is this one, the theory, and there's another one which is paper 3, which is a practical paper. So today I'll be explaining you all of the questions in this paper, the theory ones, and showing you all the calculations that you require along with any conceptual understanding which is important for solving that specific question. Before that, if you're new to this channel, do not forget to like, share and subscribe for more helpful content, especially for the upcoming May-June 2025 series. Alright, let's get started. So the first thing is the data sheet, which has certain constants such as the acceleration of free fall, and there are certain formulas given as well, so you don't need to learn these formulas, and these are pretty useful, so please do remember these formulas, or at least know that these do exist so that you don't forget to use them. Now the first question is, explain what is meant by the accuracy of a measured value. Now when we talk about values, there's always two things. There's an accuracy and there's precision. So accuracy basically tells you that how close the measured value is to the true value. Accuracy refers to how close the measured value is to the true value. Alright, I hope this is a pretty self-explanatory definition. For example, you were doing an experiment to determine the value of G, which is 9.81. This is the true value. You determined two values. One was 9.76 and your friend determined another value which was 9.83. So which one is actually more accurate? The obviously 9.83 is more accurate because it is more closer to 9.81 than 9.76. This is essentially what accuracy means. There's another term which is called as precision, which basically means that how consistent you are with the readings. Alright, but that is not being discussed here, so I'll not discuss that today. Two solid cubes A and B are measured to determine the density of the materials. Table 1.1 shows the measurements for cube A. Show that the calculated density of the material of cube A is 8.7 into 10 raised to 3 kg meter cube. Now the first thing that you really need to understand is what is the formula for density. The formula for density is rho is equivalent of the mass over the volume, although you could say this in the word form as well, that is density is equivalent to the mass divided by the volume. Now what is the mass? They're saying the unit is kg meter raised to -3. So you have to take the mass, which is 31.3 into 10 raised to -3, because grams to kilograms will be divided by 1000. So when I raise to 10 raised to -3, I'm essentially dividing it by 1000 divided by the volume. Now the volume is given in centimeters. It's the length is given. It's not the volume. So first of all, I have to change this to meters. 1.53 into 10 raised to -2 would give me this reading in meters. And then I would cube this because it's a cube, so length cube would actually give me the volume. When I put this entire thing in my calculator, so 31.3 into 10 raised to -3 divided by 1.53 into 10 raised to -2, the whole cube, it is essentially giving me something like 8739.167132, which can be written as 8.7 into 10 raised to 3 kg meter raised to -3. All right. Now the next question is, calculate the percentage uncertainty in the density of the material of the cube A. Now the percentage uncertainty, because it's actually a division, we have to add up the percentage uncertainty of the mass plus the percentage uncertainty of the volume. Now the percentage uncertainty of the mass, it will basically be we have 0.5 over 31.3, 0.5 over 31.3, that is the absolute uncertainty, multiplied by 100. Okay, we're going to leave it this as over here, plus. Now, the next thing that we need to do is add up the percentage uncertainty of the volume. Now, because the volume is not given, we have the length values. The length values are being cubed, and whenever we have a power cube, we always have to multiply that for the percentage uncertainty. So because it's a power 3, 3 into, now what's the absolute uncertainty? It's actually 0.01 over 1.53 multiplied by 100. If you're not clear, basically the percentage uncertainty is 0.01 over 1.53 into 100, but because we're cubing the length, we have to multiply this with 3. Now when I put this in my calculator, it would be 0.5 over 31.3 into 100 plus 3 into 0.01 over 1.53 into 100 into 100. Now what does that give me? That essentially gives me 3.55%, which can be this is giving me, hold up, so I'm getting 3.55 822 8403, which is essentially can be written as 3.6%, or you can also write it as 4%. Both of them would actually work. One significant figure or more than one would actually work, but I would recommend writing at least two significant figures because all the values are given to significant figures. So we are done with these both parts. Now remember, I'm writing the entire values down over here just to make sure that you guys can verify calculations, but they're not important. The density of the material of the cube A is determined to be 9.2 into 10 raised to 3 kg meter negative 3 plus or minus 6%. State and explain whether or not cube A or cube B could be made from the same material. Now ideally we see that cube B's density is greater than cube A's density, but we also know that there's a percentage uncertainty. So how about I actually find out that what could be the maximum value of cube A's density? 8.7 into 10 raised to 3. If I multiply this with basically 103.6%, it gives me 9.013. Okay, so we know that first of all, the density of cube A, the density of cube A could be as high as 9.0 into 10 raised to 3 kg meter raised to negative 3. If you're wondering how I got this value, I had 8.7 into 10 raised to 3 and I multiplied it with basically 103.6%. This gave me this value. Why did I multiply with 103.6%? Multiplying by a percentage greater than 100 will basically mean that you're taking the original value plus adding a 3.6%. So it is like increasing the value by 3.6%. It gives me this. Whereas the density of cube B, because uncertainty could be plus or minus, so the density of the cube B could be as low as, now we need to figure out that how did we actually get this. It says plus or minus 6%. So I'm going to do the 94%, the 94% of 9.2 into 10 raised to 3 as 8.6 into 10 raised to 3. And how did we get this value? Basically 94% into 9.2 into 10 raised to 3. We're basically finding out the lower value of the density which could be possible considering the percentage uncertainty. Now if you consider these ranges, you see that they both could lie in each other. Therefore, cube A could be made from the same material as cube B. Cube A could be made from the same material as cube B. Alright, so I'm going to show up the question here because I read one of the comments a few days ago which said that you want to see the questions at the end of the question to take a screenshot or maybe just review the whole question. So I'll do this throughout all of the questions if you want to check your answers or something. Okay, now state the principle of moments. The principle of moments is very easy and it's a very repeated question. What it actually says that for a system in equilibrium, for a system in equilibrium, the total clockwise moment. Now remember, the word total itself is very important. The total clockwise moment about a point is equal to total anticlockwise moment about the same point. About the same point. So the principle of moments is essentially very easy, and what it says is that for having any system that is in equilibrium, the total clockwise moment about that point will always be equal to the total anticlockwise moment about that same point. Okay, I hope this definition is clear. A solid plastic cylinder, it actually floats in water. It is used to support one end of a horizontal uniform beam AB as shown in figure 2.1. The beam now, okay, so we have a hinge. There's a solid plastic cylinder which is flowing in the water, and it is being used to support the beam which is AB as shown in the water. The beam has a length of 6 meters, which is given, and a weight of 1700 newtons. It's a uniform beam, so weight would act exactly in the center at like 3 meters from here. At 3 meters, the weight would act, which is 1700 newtons. Okay, the beam is attached to the solid ground with a hinge at actually aim. The cylinder is floating vertically in the water. The top of the cylinder is attached to the center of the beam at a horizontal distance of 5 meters. So the distance between A and the hinge and the cylinder is actually 5 meters. The cylinder applies a vertical force of 1300 newtons to the beam. A person of 660 newtons attached stands on the beam at the point B. By taking moments, we work out the moments about A. Now, essentially, you see that there are only three forces that are acting on this. So there's a weight force of this person. Now, how much is this person? It's actually 660 newtons. So there's a weight force of this person acting at a distance x, which is not known. And I think that is what you have to figure out. There is another one, which is actually the weight of the rod itself, that would also be acting downwards at a distance of 3 meters. And that weight is 1700 newtons. Now, how do I know that's 3? Because of uniform rod. But then there's a vertical force from the cylinder that's upwards. It's applying a force of how much? It's applying a force of 1300 newtons. Now, first of all, we know that the clockwise moment is equal to the anti-clockwise moment. So that is something to write. Clockwise moment is equal to the anti-clockwise. The clockwise moment and the anti-clockwise moment, they both are equal to each other. So once I know that the clockwise moment is equal to the anti-clockwise moment, I need to figure out that which of my forces are applying a clockwise moment. Now, obviously, the weight of the person and the weight of the rod, they both are clockwise, whereas 1300 newtons is anti-clockwise. The weight of the person is 660 newtons into x plus 1700 newtons, which is the weight of the rod, into 3, which is the distance from the hinge, is equivalent of 5 into 1300, which is the upward force provided by the cylinder into the distance x. Now, in order to find x, what I do is that 5 into 1300 minus 1700 into 3 divided by 660. When I put this in my calculator, 5 into 1300 minus 1700 into 3 divided by 660, it actually gives me 2.1 meters. In two significant figures, the answer is 2.1 meters, and that is the correct answer for the distance. The bottom of the cylinder is submerged in the water to a depth y as shown in figure 2.2. The beam is still attached to the cylinder but it's actually not shown. The cylinder has a mass of 11 kg and a diameter of 0.78 meters. The beam exerts a vertical force of 1300 newtons on the cylinder. The cylinder is in equilibrium, so the upthrust acting on the cylinder is 1400 newtons. Now, what are they essentially saying is that the cylinder is still attached to the beam, but the beam is not shown here. At this point, you have two forces that are acting on this cylinder. Now, there's a force on the beam which is acting downwards of 1300 newtons, and this must be the same force because it's the Newton's third law that the cylinder applied a force of 1300 newtons on the beam, so it's applying the same magnitude force but in opposite direction. So that is one force. Another force is the weight force, which is acting downwards, and that will obviously be 11 into g because that's the weight. That force will equal, both of these downward forces will equal to the upward force because it says an equilibrium. So the total upward force should be equal to the total downward force. And therefore we have to work out that the upthrust is this. So we know that the upthrust force, I mean, no, sorry. Let's take the upward force is equal to downward force. Upward force is equivalent of the downward force. If the upward force is equal to the downward force, now what are the downward forces on this? The upthrust is over here is equal to downward forces, which are 11 is the mass into the value of g, which is 9.81, plus a 1300 Newton force. Now, when I solve this in my calculator, the upthrust value is 11 into 9.81 plus 1300 newtons, which gives me 1407.91. To two significant figures, that is exactly 1400 newtons. Now, the water is the density of 990. Calculate the depth y. The water is the density of this. Then we're supposed to calculate the depth y. Now, first of all, we need to learn for this question the upthrust formula, which is force is equivalent of the density into g into v. This is given in the datasheet at the beginning of the paper. Now, the thing that we need to understand is we know the upthrust force, we know the density, and we know the value of g as well. So how about we first of all find the v? V basically refers to how much volume is displaced by the cylinder, or essentially the volume of the cylinder in the water, which is this part. Sorry, this part, not the above part, only the volume of water that has been displaced by a cylinder. So written down the formula for the upthrust. The upthrust is 1400 newtons. 1400 newtons divided by the density, which is 990 into 9.81. This will give me the volume. The volume is 1400 over 990 into 9.81. This gives me 0.1441530.494. I'm using the exact value here because I'm not done yet with my calculation. Now this volume, it will actually equal to the depth y into the area of the cylinder. The depth y into the area of the cylinder, right? Now what is the depth y? Depth y into the area of the cylinder, because the volume of the cylinder is given by the surface area into height into the area. Now the volume is given 0.1441530.494 is equivalent to y into the area. How do you find the area of a circle? Because the top surface will actually be a circle. Area of a circle is given by pi r square. So pi into the value of r square. Now do we know? Okay, they've given us a diameter over 0.78. So we can just do the 0.78 divided by 2 because it's pi r squared. The radius will be divided by 2, the whole squared. Then it's very easy to find y, which will be 0.144153.0494 divided by pi into 0.78 over 2, the whole square, divided by pi into 0.78 over 2, the whole square. This gives me 0.3 meters. I hope this question is clear as well. So essentially, I just want to show you all the working. This was the first question, first part A. Then we got part B. Then we had part C. And then we had part D. It's very easy to work out this calculation. First, for the last part, first to calculate the volume of the displaced water or the volume of the object. And the volume of the object, it will then be the area, which is the y, I mean the depth into the area, which is given. And then I found out the value of y. Pretty easy. Now let's move on to the next part of this question. The person can stand anywhere between A and B. On figure 2.3, sketch the variation of the bottom of the cylinder with the distance of the person from edge. The distances should be between 0 and 6 meters. Numerical values are not required. Now this is an understanding question. They're basically saying that he can actually stand anywhere on this rod between here and here. So then when the person moves, let's say from, okay, hold up. As the person moves from like towards B, How does the distance of the cylinder actually affect? So when you see that the person moves towards B, the moment of the person about point A will actually increase. So we need a larger, like force from the cylinder to go against that moment. So larger force will be generated by a greater depth. So obviously, as the person moves towards B, the depth must increase. But the second point to consider is, so now we know that the gradient of the graph will be positive. But will the graph pass at the origin? No. Because if the depth of the cylinder is zero, which means it's essentially out of the water, will it actually provide any upthrust force? No. The upthrust is only provided that when it's in the water. So that's why the graph will start on a positive y-axis and it will have a positive gradient, which will look somewhat like this. So if I take my ruler, the graph would look somewhat like this. You don't need any numerical values. Why is the distance as the person moves far, his movement increases, so we increase our depth so that we can provide a larger force, and the depth is not zero because if the depth is zero, there will be no upthrust force, okay, causing a resultant clockwise moment. Next up, a truck of a truck R of mass 9,400 kg. It moves with a constant acceleration in a straight line down a slope as illustrated in figure 3.1. At point A, the speed of the truck is 13 meters per second, and at point B, the speed of the truck is 22 meters per second. A and B are a distance of 180 meters apart. Calculate the acceleration of the truck between A and B. Now, for any type of question we use kinematics, and you know that you have to use the Suvat equations. I often like to write them down like this. Now, what is S? The distance is 180 meters. The initial speed is 13 meters per second. The final speed is 22 meters per second. And we want to find the acceleration. Pretty clear that we have to use the formula v squared minus u squared is equivalent of 2as, and a is actually equivalent of v squared minus u squared divided by 2s. The v squared is actually 22 squared, the u squared is 13 squared, divided by 2 times 180 meters. Now simply put this in a calculator and you would get 22 squared minus 13 squared divided by 2 into 180, which is essentially 0.875 meters, which can be written as 0.88 meters. Determine the gain and the kinetic energy of the truck between A and B. Now we know that the formula, so basically because they're at different speeds, we just need to calculate the difference in the kinetic energy. So the energy in the form of kinetic energy is given by half into mv squared. When you do half of the mass of the truck, which is 9,400 into the velocity square. What was the final velocity? It was actually 22 square. Subtracted with the initial velocity. Half into 9,400 into 13 squared. So 13 squared give me initial kinetic energy, 22 squared give me the final kinetic energy. So the difference of them, it will give me the gain in the kinetic energy. Half, now when I do half of 9,400 into 22 squared minus half of 9,400 into 13 squared, that gives me basically 14,805,00, which can essentially be written as in two significant figures 1.5 into 10 raised to 6 joules. Okay, I hope that's clear. Now let's move on to the next question. A short time after passing truck B, the truck R had moved in a straight line on a horizontal ground. The driver of the truck then applies a brake. Figure 3.2 shows the variation with time of the momentum of the truck. Now, as we can see, the momentum changes because the driver is applying the brake and eventually reduces to zero. Define force. Now, in AS level, the force is defined as the rate of change of momentum. You cannot say the product of the mass and the velocity, that would be wrong. The rate of change of momentum. And which equation it basically deriving this formula is because the change in momentum is given by the force over the force into the time is equal to change in momentum. So the force will equal to the change in momentum over time, which is essentially the rate of change of momentum. Show that the average resultant force acting on the truck R between t0 and 15 seconds is negative 1.2 into 10 raised to 4. Now again, the formula is force is equivalent to the change in momentum over the time taken. Now, if I want to determine the force, I need to determine the difference in the momentum, which is basically the final momentum minus the initial momentum. So what was the momentum at time 15 seconds? As you can see, 15 seconds is on this line. So the momentum is 2.5 into 10 raised to 4. The final momentum is actually 2.5 into 10 raised to 4. Now, what is the initial momentum though? The initial momentum, on the other hand, is given by the momentum which is at 0 seconds. So when you're at 0 seconds, the momentum was 21. So that is 21 into 10 raised to 4 difference of momentums divided by the time taken, which is 15 seconds. When I do this, 2.5 into 10 raised to 4 minus 21 into 10 raised to 4 divided by 15, that actually gives you negative 12.3333. It keeps on repeating into 10 raised to 3, which is essentially negative 1.2 into 10 raised to 4 newtons. Okay, I hope that's clear. We determine the change in the momentum between 15 seconds and 0 seconds divided by the time would give me the force. An identical truck S, it has the same initial momentum as truck R. So it has the initial momentum is 21 into 10 raised to 4. Truck S experiences a constant force equal to the force in BI. So it experiences a constant force of negative 1.2 into 10 raised to 4 newtons, whereas this truck was experiencing just an average force. The force was not constant. State and explain whether truck S will actually take more time, less time, or the same time as R. Now we can calculate the very easy question. We can actually use the force value and the initial momentum value to calculate the time taken for the truck S to come to rest, because it has a constant force. So the time taken, wait, let's do this. The time taken for S to come to rest. It will equal to the change in the momentum in the truck. Now the change in the momentum in the truck will obviously be 2.5 into 10 raised to 4. Alright, hold up. So if you want to determine the change in the momentum of the truck, we have to take this values again, which is for truck S, the initial momentum was 21 into 10 raised to 4, sorry, 21. Because the initial momentum was 21 into 10 raised to 4, so we know 21 into 10 raised to 4, and divided by the force. Now what is the force value? The force value is actually 1.2 into 10 raised to 4, which is 17.5 seconds. Okay, when you put 21 into 10 raised to 4 divided by 1.2 into 10 raised to 4, you would get 17.5 seconds. So that is the time taken for truck R to come to rest. Whereas for the other truck, it actually took, it will take more time. Now, if you want to, this is the time for truck R. Let's try calculate the time for truck S. So time taken for S to come. Now the next thing is time taken for R. The time taken for R to come to rest. I think this value can be received from the graph. So you see that at 23 seconds actually came to rest. So 20, I mean, is it 23? Sorry, it is 21, 22. You can either say 22.5 or you can say 23 seconds. I'm going to put it to 23, which really does not matter because it's still data, right? So time taken for S. Now we're going to say that the change in the momentum for both the trucks is the same. Change in momentum for both trucks is the same, and hence we can see by the calculations that S takes less time to come to rest. S takes less time to come to rest. Okay, let me just explain this question to you again if you're confused. So first of all, there was a graph given for a momentum and time. They were asked to define force, which is easy, and they were asked to work out the resultant force, which is the change in momentum over time. So between at 0 and 15 seconds, we got the change in the momentum. If we divide that by time values, we'll actually get the force value. Now, if we use this force value and the change of momentum, which is 21 10 raised to 4, we know that the truck S, it will come back, it'll come to rest at 17.5 seconds, whereas the truck R, it will come to rest in 23 seconds. So one truck comes to rest in 17.5 seconds, the other truck comes to rest in 23 seconds, and the change of momentum for both the trucks is the same. So obviously, truck S comes in rest time quicker than truck R. However, if you have any other further doubts, please do not forget to comment down below. Now let's move on to the next question. The next question is this one. A device containing a microwave emitter and a receiver is placed in front of a large metal sheet in the vacuum as shown in figure 4.1. The line XY is actually, so there's a microphone emitter in this metal sheet. The, the line XY is perpendicular to the metal sheet. Okay. After that, it says that the device emits microwaves of constant frequency 6.3 gigahertz. When the device, now 6.3 gigahertz is 6.3 into 10 raised to 9. When the device has a position B, stationary wave is formed between. Let's explain how a stationary wave is formed. So first of all, what happens is that there's a normal progressive wave which is emitted from here. It is reflected, and when both of these waves basically superpose, or when they interfere with each other, when they superpose, then they form a stationary wave. So that's what we have to write. We'll write that first of all, a microwave, which is the wave that is being generated by the emitter, a microwave from the transmitter, a microwave from the transmitter is incident on the screen. So is incident on the screen. And what it actually does is that it reflects from the screen. There's a wave which is incident on the screen, and then that same wave, it actually reflects from the screen. Then what happens is that because it reflects along the same path, the incident and the reflected waves superpose. The incident and reflected waves interfere slash superpose with each other, which is essentially just meeting each other with each other. Then it says that we have to also explain how nodes are formed and how antinodes are formed. So basically, when the waves meet in phase, the resultant amplitude maximum and an antinode is formed. So we're gonna say that when the waves meet in phase, when made in phase. Now, what does it mean by meeting in phase? Is that your phase difference is essentially zero. So when the waves meet in phase, the phase differences is equivalent of zero. When the waves meet in phase, the phase difference is actually equivalent of zero. The resultant amplitude will be a maximum. Resultant amplitude is maximum, and whenever there's a maximum on a stationary wave, what is formed is an antinode, and antinode is formed. Now, what about a node? A node is a point where it's a minimum point. So when the waves meet out of phase, out of phase basically means that the phase difference is actually equivalent of 180. The phase difference is equivalent of 180 degrees. The resultant amplitude will be zero, or it's a minimum. You can say resultant, it will not be zero, yeah, it would be minimum. The resultant amplitude is minimum, and node is formed, and a node is formed. Now again, I'm going to explain a build shot using a diagrammatic method if you're not clear. So there is a wave which goes from here, and there's another wave which actually, so excuse me for the drawing, so one goes like this, goes like this, okay, here. Then there's another wave which comes back here. So because when the interference or the superposition of both of these waves actually causes a stationary wave to be formed. Now when one wave, for example, this is a wave and this is a second wave, right? So as you can see, the top of the part is meeting the top again, the crest meet the crest, and the trough meet the trough. So this is constructive interference. At this point, the amplitude will be maximum, and therefore you will form a nod. Again, at this point also, the amplitude will be a maximum, but in the other direction, but you'll still form a nod. Now, sometimes what happens is that the wave, it actually meets like the crest meets a trough. So at this point, this amplitude will cancel this amplitude, and therefore you'll actually form a node where the you'll actually form a node where the amplitude is a minimum. Now the next equation is calculate the wavelength of the microwaves. Now V is equivalent of f lambda, so the lambda is V over f. We know that V of a microwave is always 3.0 to the power of 8 in an air or vacuum, and also they are said that the frequency is given by 6.3 into 10 to 9 hertz. So it would be 6.3 into 10 raised to 9 hertz. So when you do this, 3.0 into 10 raised to 8 over 6.3 into 10 raised to 9, what is that? That is actually 0.048 meters. 0.048 meters. Okay, two significant figures. At point P, the receiver detects a maximum amplitude of the stationary wave, which is basically at this point you have detected an antinode at point P. Okay. The devices then move slowly from point P along the line XY, and the receiver detects a series of minimum and maximum amplitudes. The first time a minimum amplitude is detected by the receiver is when the point is at Q. So when you're at point Q, you actually detected minimum of that. When you're at point Q, what it detects is actually a minimum. So now what does it say is that determine the distance between P and Q. Now for this question, it is very important to understand that how a stationary wave looks like. Because you have both closed ends, you can say that your stationary wave would somewhat be like this. Let us say the stationary wave is somewhat like this. Okay. So the one of them incident, other is a reflected wave. Now what happens is, so okay, the first time you actually detected a maximum goes over here. So let this be with the point P. The next minimum after that, it is somewhere over here. Now as you can see, this part is actually just a quarter of a wavelength, because a half of a wavelength would go over here and the next half would actually be over here. I mean, not over here, sorry. This is just a quarter of a wavelength. When you do this, this is half of wavelength, and when you go all the way back up to, for example, let's say this point, it would be the full wave. So the distance between a maximum, a maximum amplitude and a minimum amplitude, which are consecutive to each other, is just half of a wavelength. So to determine this, what you're going to do is add 1/4 of the wavelength that would remind the previous question, which was 0.048, is equivalent of 0.012 meters. 0.012 meters. Again, in a stationary wave, 0.012 meters. In a stationary wave, the distance between a maximum amplitude and the next corresponding, like mean the consecutive point, which is minimum, is exactly just half of a wavelength. Okay, you can even take another point for a reference. For example, let's take this point, which is, let's say, point A. So this is a minimum point. The next part to this, it would just be a maximum. There is quarter of a wavelength, because till here it would be half of a wavelength. So obviously AP is a quarter of a wavelength, and that's how we get it. The intensity of the microwave emitted by the device is increased. Now you are increasing the intensity. The frequency is unchanged. The device moves slowly along the line XY from point Q until the next maximum amplitude detected at the point R. Steer explain whether the distance QR is greater than, less than, or the same as the distance of PQ. Now, because we see that the frequency actually does not change, and if the frequency, the speed also remains the same, so the wavelengths remain the same, and therefore the distance would not actually matter. The distance would not change. You can say that the frequency, or because the frequency has not changed, the intensity has changed. So intensity does not impact the wavelength as well. So frequency of the wavelength is unchanged, So when frequency and wavelength are unchanged, what happens is that the distance PQ, which is a quarter of a wavelength, is same as the distance QR. Again, the intensity of the wave is increased, but the frequency remains the same, and the intensity does not depend on the wavelength as well. So the frequency and the wavelength are the same, so therefore the distance QR will be the same as the distance PR. And we can also say that the distance between a maxima and a minima, or the node and antinode, it actually does not depend on the intensity, so the distance will still remain the same regardless. Alright, now we'll move on to the next question. Now we'll be moving on to question number 5. In question number 5, it says that a stationary loudspeaker emits sound of constant frequency. A microphone is placed near to the loudspeaker and connected to the cathode ray oscilloscope. The trace on the screen is shown in figure 5.1. The time base of the CRO is said to be 5.010 raised to negative 4. The speed of the sound is given, determine the wavelength. Now if we use V is equivalent of F lambda, we know that in order to determine the lambda, we would also need the value of F. But we do not have the value of F. Okay, but we also know that the frequency is equivalent of 1 over the time period, right? The frequency is equivalent of 1 over the time period. The time period is basically the time taken for one wave to complete, which we can actually determine from this. Now, if I take this point on the wave, this is the starting point. The wave goes all the way up and comes back all the way down over here. Okay, so if I can measure the distance between these two, I would get them. This is 1 centimeter, which is this much. Then 2 centimeters still here, 3 centimeters still here, 4 centimeters still here, 5 centimeters still here, then 5.2 centimeters, 5.4 centimeters, 5.6 centimeters, it's 5.8 centimeters. And 1 centimeter represents 5.010 raised to negative 4. So I have 5.8 centimeters into 5.0 into 10 raised to negative 4. Okay, so this is my frequency. Frequency is 1 over the time period, which is 5.8. This is equivalent of 10,000 over 29. This is equivalent of 10,000 over 29 frequency. Now, if I want to determine the lambda will be the V, which is 330 divided by the frequency, which is 10,000 divided by 29. I'm using the exact value rather than rounding it off. So this gives me 330 divided by my answer value. It is actually equivalent of 0.96 meters. So first of all, what I did in this question was, first of all, I determined the frequency using the equation 1 over the time period. The time period I got from the graph. Then I used V is equivalent of F lambda to determine the wavelength. The loudspeaker now moves in a straight line while emitting the same sound of a constant frequency. The period increases continuously. Now, since we know that the sound period and how are the sound period and the sound frequency related, they are inversely proportional to each other. So that means when the period of the sound increases continuously, the frequency of the sound is decreasing continuously. And when does the frequency of the sound decrease? When the sound is actually moving, or when the source of the sound is moving away from us. So one mark is for writing that the loudspeaker is actually moving. The loudspeaker, which is the source of the sound, is moving away from the emitter. And the next part, you can see that what is the importance of the word continuously. Continuously means that at every second the period is basically getting more and more bigger. So that means the frequency is decreasing more and more. That means you're going at an increasing speed because you're coming larger distance every time at an increasing speed. Okay, let me just re-explain this if you're not understood. So basically, as per the Doppler's effect, if an object, if the source of the sound or the source of a wave is coming towards you, you would notice an increased frequency and decreased wavelength. Whereas if it's moving away from you, you would notice a decreased frequency and um, increased wavelength. Okay. Now here it says that the period is increasing continuously because period and frequency are inversely proportional. If the period increases, that the frequency must decrease. If the frequency decreases, that means it's moving away from us, And it's, if the period is increasing continuously, the frequency decreases continuously, which means at an increasing speed. A cylindrical copper wire P of length 0.24 meters is shown in figure 6.1. It has an area of 0.858. The current in the wire is 0.858. The resistance is given 3.3 × 10⁻³ The total number of charge carriers, which is the total number of electrons in the wire, is 2.6 × 10⁻². The resistivity of copper is given. Calculate the potential difference between the two. Now, potential is very easy. V is equivalent of IR. So I value is 0.85 amperes. The resistance value is actually 3.3 × 10⁻³ because milliohms. Okay, so when you do this, 0.85 into 3.3 into 10⁻³ is actually 2.8 into 10⁻³ volts. Okay, 2.8 into 10⁻³ volts. All right, the next question is, show that the cross-sectional area of the wire is 1.3 into 10⁻⁻6 meters square. The resistance is actually the resistivity into the length over the area, right? So the area is essentially the resistivity into the length divided by the resistance. Now, what's the resistivity? The resistivity is given by 1.8 into 10⁻⁸, 1.8 into 10⁻⁸ into the length. The length of the wire is given as 0.24 meters divided by the resistance of the wire. The resistance of the wire is actually given by the resistance of the wire, 3.3 into 10⁻³ So when you do this, what do you get? So 1.8 into 10⁻⁸ into 0.24 divided by 3.3 into 10⁻⁻3. That is essentially 1.3 into 10⁻⁻6 meters square. Just use the formula that resistance is equal to resistivity into the length, the whole divided by the area. So the area is actually resistivity into the length divided by R if you're just rearranging it, and that's how you get it. Show the number density of the charge carriers is 8.3 and 10⁻²8. So the number density basically means that when you have the total number of charge carriers, 2.6 and 10⁻²22, you divide that by the volume. No, I mean, you divide that by the volume, yes, to get the number density. So that tells you the number of charge carriers per the unit volume of that material. The number density N is given by the capital N, which gives the total number of charge carriers divided by the volume V. The number density, the total number of the particles of the is 2.6 into 10⁻²22. So you got 2.6 into 10⁻²22 divided by the volume V. Now what's the volume? The volume is given by the area into the cross-section area, which is 1.3 into 10⁻⁻6. 1.3 into 10⁻⁻6 cross-sectional area into the volume, into the length, which is 0.24 meters. When you do this, what do you get? 2.6 into 10⁻²22 divided by 1.3 into 10⁻⁻6 into 0.24. That gives you 8.3 into 10⁻²28. Again, the number density tells you how many charge carriers do you have per unit volume. It is equivalent of the total number of charge carriers divided by the volume, and the volume is given by the cross-sectional area into the length. So you get 8.3 into 10⁻²28. Calculate the average drift speed of the charge carriers in the wire. Now there's a formula for the drift speed, that is I is equivalent of A and VQ, where A refers to the current I, cross-section area A, the number density of charge carriers is N, V is the drift speed, and Q is the charge on a single electron. So now to determine V, what I do is the current value. Now the current is 0.85 amperes divided by the area of the wire, because A would go into division, which is 1.3 into 10⁻⁶. Then the number density is actually 8.3 into 10⁻28 divided by the Q, which is the charge on a single electron, which is 1.6 into 10⁻⁻19. The value of this is given in the first page. I'll just check what is it called. Just give me a minute. So if I go to the top of the paper on my laptop, okay, so this value, it is basically called as the elementary charge. It is the third value. It is called as 1.6 into 10⁻⁻19. Now we just put this simply into a calculator to get the answer for this calculation. Okay, so when we do this, okay, just give me a minute. Yes. When you do this, 0.85 divided by 1.3 into 10 raised to negative 6 into 8.3 into 10 raised to 28 into 1.6 into 10 raised to negative 19. It is actually 4.9 into 10 raised to negative 5. 4.9 into 10 raised to negative 5. The next question is a different copper wire. It has the same volume, but it has a non-uniform radius, as shown in figure 3.2. The radius R1 at the end X of the wire is same as the radius of the wire P. The radius R2, however, initially the radius is same, but then the radius actually decreases. State and explain how the resistance of Q compares to the resistance of wire P. Now, this question requires a logical understanding and a bit of creative understanding as well. So because it says the same volume, the volume is area into length. But overall, if you see the overall area of this wire, like because at one point it's the same, but the other point is less, so the overall area will be less. So the length will be greater, right? The length of the wire will have increased because the volume is constant, whereas the cross-section area is kind of decreased. And you also see that the cross-sectional area it actually decreases along the length of the wires because R2 is less than R1. Now we know that resistance is directly proportional to the length of the wire, so the length is increased, so the resistance must increase. The resistance is also inversely proportional to the cross-sectional area of the wire, so when the area decreases, which is here it is decreasing, the resistance will further increase. Hence, overall, the resistance of the wire Q is greater than the resistance of the wire P. Now, I'm going to write it this way, that the length of the wire has increased. And how do we know that the length of the wire is increased? The length of the wire is increased. Why? Because as the volume is constant, but your area at the other end is actually less. That's why the length has increased. We also see that cross-sectional area, it decreases along the length of the wire. So basically, as we move from like one end to the other end, you see the cross-sectional area decreases. Then resistance is directly proportional to the length. We know that resistance is directly proportional to the length, and that's one thing, that resistance directly proportional to length, and it is inversely proportional to the cross. Resistance is directly proportional to the length and inversely proportional to the cross-sectional area. So because the length is increasing and the cross section is decreasing, the resistance of Q is greater than the resistance of R. Again, you see the volume is constant, so and the area is kind of lower on the other end, so the length must be greater to keep the volume constant. If the length is greater, the resistance like increases. And also as the cross-section area is decreasing, so because the resistance of the cross-section area is inversely proportional, the resistance then further increases. So overall the resistance of Q is greater than the resistance of P. Of R in fact. Sorry, is it R or is it P? Sorry. It's P. Overall the resistance of Q is greater than the resistance of P. Okay, so we've got this question done and this question done as well. If you're looking forward to take a screenshot, please do take it right now. Now the next question. Sketch a graph of the variation of the average drift speed of the charge carriers with the distance x from end x of the wire to the end q. Now we know that I is actually equivalent of, if you look at the formula we use back over here, A and VQ. Let's understand the question first. It says sketch a graph of the variation of the average drift speed as you move away from the index. That means you go towards this speed. As you go towards this side, what happens to the drift speed? Now we know that I is equivalent of A N V Q. Okay. Now because as we move to the other end, the area actually decreases. So the area is decreasing. Okay, if the area decreases, the resistance increases, and if the resistance increases, the current also decreases. So the current is decreasing, the area is decreasing, and it's a number density. I mean, it's a number density that would still be constant because it's the same for a material. The drift velocity also be constant. No, sorry, drift velocity is something I want to figure out. The q value, it again the charge is also constant. So if I is decreasing and if this is decreasing, if you want to maintain n and q as a constant, v must actually increase, right? Because we want to give a balance in the equation. If one thing is decreasing, the other is decreasing, so one must increase in order to ensure that n and q remains constant. Therefore, the graph will be a positive line. And we also know that drift speed can never be zero because electrons move even if you're a little bit off. That's only where the current occurs. So it cannot be zero. So the graph would look somewhat like this. Now I bet you've understood that why it is positive gradient. But why is it actually a curve? Because the the area, it will decrease by the power of 2 every time because the radius is squared, right? So that, and we know that the graphs of any exponentials is given drawn like this. Basically, it doesn't have to increase linearly, it will increase in a more of an exponential form. Okay, I hope this question is clear. Again, I decreases, a decreases, and n and q remain the constant. So if they both remain the constant, if two things are decreasing, one must increase to get the balance in the equation. That's why this increases, and this increases at an increasing rate because the area actually decreases at a larger rate because area is essentially the radius is squared. So this also must represent the same format, which is a square, and that's why I've drawn it like this. All right, now we move on to the last question, which I believe. So an isolated stationary sphere Q, it decays into nucleus R as well as an alpha particle. The alpha particle has a speed of 1.5 into 10 raised to 7 meters per second. Complete the equation for the decay. Now we know that in always a decay, the mass numbers and atomic numbers are balanced. So on this side I have 222 and this side I have 4, so this is 226, easy. And this side I have 88 and this is 2, so this should be 86 because 86 plus 2 is 88 and 222 plus 4 is actually 226. By considering momentum, calculate the speed of the nucleus after the decay. Now we know that in an isolated system, the momentum before the collision is equal to momentum after the collision. Momentum is equivalent of the mass into the velocity. So we'll take the mass before. The mass is actually 226. But remember that 226 is actually the atomic unit's mass. If you want to find the mass, actual mass, it would actually be 1.66 into 10 raised to negative 27. Okay. And initially it's a stationary sphere, so this should be 0. Is equivalent of the alpha particle, it is 4, the mass is 4, and we'll multiply this by 1.66 into 10 raised to negative 27 because 4 is atomic mass units, it's not actually in kgs, into 1.5 into 10 raised to 7, which is the speed, plus 222 is this next mass into 1.66 into 10 raised to negative 27 again, and what do we have is the velocity, which is v, which we're trying to find out. So it'll be pretty easy if you do this. Now 226, hold up, 226 into 0 minus 4 into 1.5 minus 7 divided by 222, 2.7 into 10 raised to 5. Yep. Now look, we can make the calculation simpler because we can divide all of the three terms by 1.66 into 10 raised to negative 27. We essentially cancel each other out. So 226 into 0, it will be 4 into 1.5 into 10 raised to 7 plus 222 into v. So this will then be the value of v is actually 0 minus 4 into 1.5 into 10 raised to 7 divided by 222, which is essentially, the answer would be negative, but because of speed you can write it as 2.7 into 10 raised to 5, or 270,000. 270,000 same as 2.7 into 10 raised to 5 is 270,000. Yes. Okay, I hope this clear. Simpler application of momentum. It does not actually depend whether you use the values of the atomic mass units to kg conversion or no. State three quantities that are conserved during a decay. So first of all, the momentum is conserved as you see in the equation. Secondly, the proton number is conserved, which is basically the number of protons in the initial nucleus and the reactants or the products. Along with that, the nucleon number is also conserved. And by doing this question, we have reached the end of this paper. I hope this video was helpful for you guys, and I hope you have cleared any doubts out of the paper. Furthermore, if you have any more doubts, please do not forget to comment down below, and I'll try to respond as soon as possible. If you have any other video suggestions or anything that you'd like to clarify, please do post on the comments below. I really appreciate any comments that ask me for questions or maybe some suggestions for next videos. Again, don't forget to like, share, and subscribe for more helpful content. Share this video with your friends. And if you feel this video super helpful, I would appreciate you could buy a super thanks or a membership for the channel, which gives you a lot of exclusive perks. See you in the next video. Take care and goodbye.